What's up, math fans? If you saw my video on how to solve a circle line system, then this one's gonna be really easy. All right, how to solve a quadratic linear system. So what that means is they're going to give you two equations. Here they are, and one of them is a quadratic and one of them is linear. You can tell it's a quadratic because the highest power of x is a 2. Here it's linear because the highest power of the x is a 1. So then you have to kind of get just a picture of it. You don't have to graph it, but actually graphing it kind of gives you a great idea of what you're looking for. So the solution is where this line intersects this parabola. So you could get a graphing calculator and you would type this in, right? But it's not that easy because you need y alone first. So you need that skill of getting y alone first. So I would take each one and try to isolate my y. So if y plus 7 equals x squared, I'm going to subtract 7 on both sides, and y equals x squared minus 7. And then you graph that. Same thing here. If 6x plus y equals negative 16, then I subtract 6x on both sides, and y equals negative 6x minus 16. I have a parabola, I have a line, I press graph, and I get a nice picture. So I'm going to just guesstimate because I learned some things already about graphing. I know that this is a parabola, and I know my vertex is 0, negative 7. So 1, 2, 3, 4, 5, 6, 7 right here, and the parabola is going to open up. And I'm just doing a quick sketch because this video is going to teach you algebraically, not graphically. And then this one is a straight line that starts at negative 16. So if this was 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 is here. And then it goes down 6 over 1. Down 6 over 1, right? Because that slope is negative 6 over 1. Or I could go the opposite way and go up 6, left 1. So if I went up 6, left 1, I'd be here. If I went up another 6, 1, 2, 3, 4, 5, 6, left 1, I'd be, I think, here. This is not the best picture, but I'm getting an idea that there's a line and a parabola, and they might meet somewhere over here. Again, on a graphing calculator, it's going to be clear to you, and you can even press the buttons second, and then there's a button that says calc, and you want to calculate the point of intersection. So then you would choose wherever intersection is, and then it would ask you 3 questions. Left curve, so you bring your cursor to somewhere over here. Right curve, you bring your cursor again somewhere over here, and then guess. Each time you press enter. By the 3rd time you press enter, they'll give you the coordinates, all right? So that's the easy shortcut. But if you have to solve this algebraically, I'm going to use a method that I've already taught called elimination or substitution. Which one is best? I'm going with substitution here, all right? So since I already did the work to get y alone, I know that y equals this thing. So I can take this thing and replace it with this y. Or I could even replace it with that y. Doesn't really matter. Here's a y. So I'm going to write 6x plus y. No, wait. Plus that. Equals negative 16. Equals negative 16. Now I've got an easy quadratic equation that I'm going to get in standard form. Standard form means one side has to equal 0. So let me add 16 to both sides. And let me put this in order of highest power first, known as descending order. So I got x squared plus 6x, this is going to be plus 9 equals 0. Now it's in standard form, and how do you solve a quadratic? You factor, use a t-chart. If you can't factor for whatever reason, you can always use the quadratic formula. So I'm going to do it both ways. You can fast forward or pause for whichever is your favorite way. Alright, I know that x plus 3 times x plus 3 gives me x squared plus 6x plus 9. It's actually a perfect square trinomial. It happens to be that way, not always the case, equals 0. Then I have my t-chart. Either this side equals 0 or this side equals 0. I've created 2 linear equations now, one-step linear equations. Subtract 3 on both sides, and I'm going to get x equals negative 3. If I do it here, I get the same thing. So that's the same answer. I only need to write it once. The answer is x equals negative 3. But if I'm solving, I need x and y. You gave me x and y, I have to give you back x and y. So I'll go back to my favorite equation. Doesn't really matter. And I'm going to plug in negative 3. So I'm actually going to go here. Y plus 7 equals x squared. So y plus 7 equals negative 3 squared. So y plus 7 equals 9. So if I subtract 7 on both sides, y equals 2. And my point of intersection is -3, positive 2. And I just want to make sure that's correct, so I'm going to take this -3 and plug it in here. So that's -18. I add 18 to both sides, and again, y equals 2, so I'm good. So as you can tell, me quickly sketching was not helpful. Graphing calculator will be much more helpful. And you'll see that your point of intersection would be -3, 2, which is actually a lot higher, somewhere up there, okay? So don't quote me on that, because I didn't use the graphing calculator. But my point, my solution is -3, 2. And I did promise that just in case you can't factor, is there another way to do this? Yes. So hopefully you got that. So now I'm going to do it another way. I'm going to say, I can't figure this out, but I do know that it's in standard form. I know that A is 1, my leading coefficient is 1, B is 6, and C is 9. If you can read off those three coefficients, you can use the quadratic formula. Remember that song? X equals -b plus or minus blah blah blah, all over 2a. Remember, it's all over 2a. People cut this line short for some reason. So let me plug some stuff in. I have x equals -6 plus or minus the square root of 6 squared minus 4 times 1 times 9 all over 2 times 1. See if I can save some time and do this in one shot. So -6 plus or minus 36 minus 36, that's 0. The square root of 0 is still 0. 6 plus or minus 0. 6 plus 0 is 6. 6 minus 0 is 6. Oh, it turns out to be -6. -6 plus or minus 0 is still -6. So I don't need that. The whole thing canceled out on top. This is all 0. And now that's all over 2a is 2, right? Well, that means that x equals -3. I got the same answer no matter how you do it. Take the -3, plug it in, you will get 2. There is your solution, also known as your point of intersection. The maximum amount of points of intersection in the quadratic linear, 2. You could also get 1. It's possible to get none. Thanks for watching. See ya.